Hello friends, welcome to our yet another video on geospatial analysis using Python and Geopandas library. So today we are going to work on Geopanda library and we'll perform various geospatial analysis like intersection, union, dissolve, spatial join, etc. So you can see over the screen here I have opened a Spyder that is IDE for Python development, and we will start writing the code here. So on the left panel you can see it is untitled.py. This is where we can create our new Python file, and on the right hand side we have Python console where we can see the output when we execute the code, or we can even write small one-liner code here and see the output. This is a files tab, which is nothing but like our Windows Explorer. We can browse to the folder from here and we can see the content of that folder in this display area. There is a help menu. We can get help of various commands. This is a variable explorer. So whenever we declare any variable in our Python file, we can see the content of that variable over here using variable explorer. This is plot. So when we are plotting something, for example when we display some shapefile and we use the plot command, it will be plotted here. And this is a history of commands that we can see. So in plots we have option like mute inline plotting. So if I mute it, it will plot only in this plot area, but if I uncheck it, it will also plot into my console. So first of all, let us save this Python file. It is a blank, so let me save it somewhere. So I will save it in my D downloads. I have created a folder GP training, and in that I will save it as a GP training.py. It is extension for Python, so I am saving it. So my file is saved with GP training.py, and now we will start writing code here. So we'll start with importing some libraries. So first of all we will import Geopandas as GPD. We will also import matplotlib, this will support plotting functionality. We are also importing basic pandas as PD. Why we are writing here as GPD or as PD? Because when I use this thing into the program, I don't have to type pandas or geopandas. I can simply use GPD or PD instead of typing these full words. So that is why we are using as PD. And I am also importing point library from Shapely. So from I have imported point library from Shapely. Now let us start writing the code. So first thing that we are going to do is we will display the shapefile. So we will plot it. So let us do that. So I am putting just a comment here that this is the first function that we are going to do, that is plotting a shapefile. So let me declare a variable states is equal to gpd dot read underscore file. This is the command I have to use, and from where it will read the file. So right now my current folder is something else, but I'll change it to D downloads GP training. So I have selected that folder. You can see over here D downloads GP training. So if I click the files tab now, so it is showing me all the files that are located in this folder. It is like a Windows Explorer. So you can see in GP training I have some data, some shapefile and CSV files. Similarly, it is also showing all the files over here. So we'll be using this AOI shapefile and then river, roads and states. So you can see over here, this is the states shapefile. It is nothing but a state boundary for India. So we'll be displaying that file over here. So that file is located in D downloads and GP training folder. So I'll copy that path, and here I'll first of all write R because I want to read the file, and then I'll copy the path. Next I have to do is I have to copy the file name. So I'll just copy it from here and I'll paste it here. So this is the full path I have given, but right now you can see gptraining.py, it is in the same folder where I have a state shapefile. So I can simply type the state.shp. It is not required to type this complete path, but for your understanding right now I am typing the full path. So we are asking Geopandas to read this shapefile. So it is reading it, but now we have to plot it. So we can simply write states, which is the variable, and plot. It is very simple in Python. Now let me save this file and let me execute it. So when I execute that file, it is reading this file, and you can see over here it has plotted the states boundary. You can see India state boundary, and state boundary is displayed with a white color in the blue background. You can see over here. Now if I want to give some symbology to it, I can give it here. So now let me give some color is equal to say red, and then I want to give edge color is equal to say black. Now let me save it and execute it again. So it will read the shapefile from this line and it will plot based on the color symbology we have given. Now let me execute it. So you can see over here the color is red and the edge or say border line is displayed with a black color, the way we have defined over here. Now if we go to the variables explorer, you can see over here we have declared one variable state, so it is available over here. It is a Geopandas data frame, so type is a data frame, and it is 36 by 4. It means that it has got 36 rows and 4 columns, and the columns are GID, name, type, and geometry. Geometry is the column which is storing all x and y coordinates or latitudes and longitudes. Name is I think for the state name, and it is a type field, and GID is a unique ID field. So these are the 4 attributes. Now if you want to display the state boundaries with different unique colors based on the name field, so here we have name, so based on the state name it should assign some unique color, the way we do in all GIS softwares. We can do it here using Python Geopandas as well. So let us see how to do that. So here when I have given colors is equal to red, instead of that I would say that CMap is equal to HSV. It means that it has to use color map of HSV category, and then it has to use column name, that is equal to name. So it has to follow the column name, and it has to give unique color to each and every states. It has to follow this symbology, and edges will remain black. So that's what we have given. Now if we want to increase the size of this plotting area, then we can pass on one more argument, that is fixed size equal to 10,8. That is the size we want to give. So it will be slightly bigger so we can see it properly. Now let me execute that. So we will see the output in this plotting area. Now you can see it is looking beautiful. It is slightly bigger, and each and every state has got different color, and the edges are black. Now if I want to remove the edge and just give the color, I'll simply remove this thing, save it and execute. So it will look beautiful. Excellent. So we can do basic symbology. So this is all about displaying a shapefile. Now what we want to do is, many times we want to display partial data based on some attribute value. You can see over here, let us see what has got in the name. So what we will do is, I will type states and then I'll give name as a input. and then let us see what is there in the name. You can see over here it is plotting all the rows. So there are 0 to 35 means total 36 rows, and this is what is there in the name field. So all the state names. So now for example, if I want to display only Gujarat state, which is there in the name field, so what I have to do, let us see. So let me declare another variable Gujarat, and then what I'll do is I'll use states variable, but then I will filter it out based on some value. So I'm filtering out states based on state name field, and it should be Gujarat. So now only Gujarat polygon is there in this variable. Again I can plot this Gujarat. So now when I plot it, you can see in this line I am plotting complete India, and in this line I am plotting only Gujarat. Let me save it and execute it. There should be two plots. You can see the first plot is related to this line, which is plotting entire India with different state colors, and here I have Gujarat, which is coming out from this plot where I am filtering this thing based on state name. So isn't it beautiful? So like this you can fire any query, and then you will be plotting based on the filter. So it can be a numerical field, it can be a text field, or it can be a Boolean field. You can filter the data like this. So what we have done is we have plotted a shapefile, and we have applied attribute filter. So I'll update the comment part. So now this is one thing. Now let us move to the next thing. Now what we are going to do is, in case you want to change the coordinate system of this file. So first of all, let us see what is the projection or coordinate system of this file. So we can check the coordinate system either of states variable or Gujarat. Both have the same, because it is nothing but a filter part of it. So let us check the coordinate reference of states, CRS. So here you have to use this variable and then simply type CRS. Now when I press enter, you can see it is providing EPSG code 3857 and the detailed description of that EPSG code. The projection system is WGS 84 and it is a pseudo marketer. So attributes will be stored in terms of meters. So you can see over here easting and northing, everything is in terms of meter, and then other details of this coordinate system. So basically it is a WGS 84 with pseudo marketer. Now what if you want to convert this from EPSG 3857 to EPSG 4326? 4326 is nothing but a WGS 84 wherein attributes or coordinates will be stored in terms of a decimal degree, latitudes and longitudes. So let us see how to change the coordinate system. So let me write the comment first. So we are writing a code for changing the projection and then exporting to a new shapefile. So let us see how to do that. So what I will do is, I want to export only Gujarat, or I can export even entire state. So let us start with exporting Gujarat. So I will say Gujarat underscore 4326, that is the new file which will be created. So I am giving the variable name accordingly, and what I have to do is, it is very simple. I will use this variable Gujarat and simply I have to write to CRS. It is very simple, you can see, and EPSG is equal to 4326. It is just like that. So you have created a new variable, and this variable is storing a Gujarat boundary file, but it will have the projection system this. Now if I want to export this thing, then Gujarat dot to underscore file. This simple command will export it into shapefile. So let me give the file name. So I am giving the file name Gujarat underscore 4326.shp, and then I have to provide the driver, that is equal to Simple. A small single line item will export Gujarat shapefile into 4326 coordinate system. So let me save it and let me execute this thing. So here you can see the first line, it is plotting over here, which is this area. Second, it is plotting over here, which is this area, and this line is basically converting the projection and exporting to shapefile. So it is performing this export operation. Now we can see in this files area, do we have Gujarat 4326? Yes, we have that shapefile. We can display it over here. So we have understood how to export file from one projection coordinate system to other coordinate system and ultimately export to a shapefile. So isn't it beautiful? Don't you find that Python is very simple and very intuitive language? You have to write the syntax as if you are talking to somebody or you are asking somebody to do something. It is very much vocal kind of a programming language. So let us move ahead. Now let us display the roads of India. So what I'll do is I'll comment this part of a code because we have understood this thing. Now I am displaying the roads. So let me create a variable roads, and again we'll use this commands. I'll just copy and paste it over here, and here rather than typing the full path, let me show you. I can type only shapefile name because my Python file and shapefile both are in the same folder. Now here I'll comment this portion also because we don't want to print Gujarat. So what we are doing is we are plotting state shapefile here and we are plotting a road shapefile here. So let me write the plot command, and here we'll be giving color is equal to black. So we are plotting this thing. Now let me execute. What we should expect? One map with a state file, other map with a roads file. Let me give this also a figure size of 10,8 so that both will look approximately same size. Now let me execute that. We should expect two plots. Because road is slightly lengthy file, it will take some time in reading and plotting. So you can see over here, first it is plotting India states based on this line, and second it is plotting roads based on this line. You can see over here roads of India. Now what we want is, I don't want to plot states and roads separately. I want to plot these two layers overlaying on top of each other. So let us understand how to do that. So rather than plotting separately, so I'll comment this line where I am plotting shapefile. I'll comment this line where I am plotting roads. Now what I am going to do is I want to plot them together. So what I have to do is, so let me write comments first. What we are going to do now, what I am doing is I am declaring variables figure and ax, which is for axis, and then I am using matplotlib functionality. So using plt dot subplots, and then I am providing fig size a parameter which is 10,8. So this is the subplot I have created, and now let us plot. So I will copy this line to plot the states. So let me copy that. So I am writing states to plot, but here I have to provide axis is equal to ax. You can see over here. So I am asking the states plot to plot on the ax axis. At the same time I will also plot roads. So I will copy this line and it will also be plotted on ax is equal to ax. So both are plotted on the same axis. Now here, because we have given figure size into the subplot area, it is not required to give figure size in separately for both the plots. So I'll remove that. So you can see over here I have created a variable with subplots, and then I am plotting states and roads on the same axis. Now when I save it and let me execute it, what we should expect? States and roads overlaid on top of each other. As such, yeah, you can see over here we have states file and road file overlaid on top of each other. So excellent, we are able to overlay shapefiles on top of each other. So far what we have learned is how to display a shapefile, how to filter based on attribute and display partial data, how to convert from one projection to other projection, and then ultimately create a new shapefile. We have also seen how to overlay multiple shapefile on top of each other. So now there is no limit, like you can have point, line, polygon overlaid on each other with different styles and symbology. So you can experiment separately. So we will move ahead. Now we will understand various kind of a geospatial functionalities. So for time being, I'll comment this states variable, roads variable, and this particular function, because we are going to write something new. So let me start writing code for displaying area of interest. You can see over here in this files GP training folder, I have AOI1 shapefile, AOI2 shapefile, I have reverse shapefile. So these are the three shapefiles which we will be using to understand various kind of a geospatial analysis using Geopandas. So let me first of all write the code for displaying all this area AOI1, AOI2 and reverse. So let me quickly write the code for that. So by now you understand how to display multiple shapefile on top of each other, so you can follow the code. So we have created a figure and axis variable. Now I will say AOI1 is equal to so I am creating a variable AOI1 to display, to read the file AOI1.shp. Now let me just copy it from here and put it on top. Now I will create AOI2 variable and then I'll read the AOI2.shp. Let me also read river and copy this thing here, and I'll read a river file here. Now when I created this figure and axis variable, you know how to plot it on top of each other. So AOI1 dot plot and then AX is equal to AX, so that it will display on the same axis. I am giving edge color. By now you understand what is the edge color. So I am displaying area of interest 1 with edge color none and fill color is green. So let me display AOI2. So I will be plotting AOI2 with edge color red and color as none, and I will be plotting river on the same axis, and then color is equal to blue. So now you can see over here, let me execute this code. So when I execute this code, let us see. Now you can see we have area of interest 1 with fill color green. So this rectangle, this portion is our area of interest 1. This is a polygon shapefile. Second is with edge color red and fill color as none. So you can see this second rectangle is my area of interest 2, and this blue color line is my river. So these are the three dummy files which I have created: shapefile 1 with a green fill color, shapefile 2 with a red outline and no fill color, and shapefile 3 which is a line file which is nothing but a river. So I have created these three files, and now we will understand various kinds of a geospatial analysis. So let us start with the most basic function, that is intersection. So let me put up a comment. So intersection, we are writing a code for intersection. Now what we want to do is, we want to do the intersection of AOI1 and AOI2, and we want to see what is the output result. So let me do that. So I am declaring one variable intersection, that is equal to gpd dot overlay, and then AOI1, AOI2, and then the parameter how. Now you can see over here I am providing AOI1 and AOI2 as input, and how is the function that I want to perform. So I am writing intersection. So this will do the intersection analysis, and now let us plot intersection dot plot. So what do you expect? When AOI1 will be intersected with AOI2, it will generate a new file which is having common area. So it should generate this small rectangle which is common between AOI1 and 2. So let us save this thing and let us execute. So you can see over here it has generated a small rectangle which is this common portion between AOI1 and 2. You can see this portion is starting somewhere from 2.55 over here, and it is ending 2.75. So you can see here 2.55 to 2.75. So it is nothing but this small rectangle which is common area between AOI1 and 2. So it is doing intersection. Excellent. We are able to do first geospatial analysis, that was intersection. Now let us do the union. So let me comment this thing. So every time we will do new spatial analysis, we will comment the previous one, so that we can use the same file. We don't have to create a new file. So let us do the union now. Now I am creating a variable called union, and we will use gpd.overlay, same function. Now again AOI1 as one input, AOI2 as the another input, and then in how we have to write union. You can see over here we have created this function, and now let us plot union. So what we should expect? Now we have commented intersection, so it will be using this file. So this is the input file and this is the output. So let us see for union how it is working. Let me execute that. So you can see over here, this is the input file. Right now we are not using the river, so let us forget that for time being. So we have green rectangle, we have red rectangle, and when we union that, let us see the output. You can see we have an output with three different polygon. One is this L shape, other one is a common portion, that is rectangle, and the other one is upper reverse L shape. So these are the three polygons into a single file, and that is the union of area of interest 1 and 2. So you can see that. Now we have completed this union functionality. Now let us go to the next analysis, that is symmetric difference. What is symmetric difference? Can you tell me? By the name, can you guess what it is going to do? So let us first of all write the function. So I'll simply copy this thing so that I don't have to write again and again. So I'll remove these comments, and then rather than union, I'll declare the variable as SD, and then area of interest 1 and 2, and in how we will write symmetric difference. Now let us understand, we have area of interest 1, area of interest 2. Let me comment river over here. So we have area of interest 1, area of interest 2, and symmetric difference. So what it will basically do is, it will take the area of interest 1 and 2 and identify the common area and just remove that and create a new polygon which is containing only the exclusive OR area. So let us see how it is generating the output. You can see we have AOI1, AOI2, and this is the common area. So symmetric difference has eliminated the common area and generated the output like this. It is having 2 polygons. Common area is removed. This is what is called a symmetric difference. Okay. So this is another geospatial analysis, symmetric difference. Now let us go to the next one, that is difference. Now what is difference? Can you guess it? What it will do? So let me again copy this thing. I'll remove the comment and I'll declare the variable as diff, and here rather than symmetric difference I'll just write difference. Let me save it. So here what is happening is AOI1 as an input, AOI2 as an input, and I am taking the difference. Now here the sequence is very important because I am subtracting AOI2 from AOI1. So you can see this is AOI1, this is AOI2. When I am subtracting AOI2 from AOI1, then output will be AOI1 minus the common area. So here we should expect output with a polygon of L shaped. Let us save it and let us execute it. So you can see over here, as we were expecting, AOI1 minus the common area, that is the output. So this is the L shape. Now if I change the sequence, you can see over here from AOI2 I am subtracting AOI1. Let us save it and I hope you can guess what will be the output. It is a reverse L. So you can see AOI2 minus the common area, that is the output. So this is what is difference. So I hope you understand what is symmetric difference and what is the difference. Now let us go to the next geospatial analysis, that is dissolve. Those who are from GIS background, they might know what is dissolve. So let us do that functionality. Let us do a dissolve analysis. So for performing dissolve, what is the basic requirement? We should have a single file in which there are multiple polygons, and there should be one attribute at least which is common. So let us first of all, to have a single file in which we have 3 polygons, we have to do the union of AOI1 and 2. So we will copy this union code and we will write it here so that we have a union. And now let us execute this code for union. Let us see. Oh, we have not plotted the union. So let us plot it, save it, execute. Now you can see we have 3 different polygons in union: lower L shape, rectangle, and upper reverse L shape. To verify whether we really have 3 different polygons or not, union is a variable. You know where to go, variable explorer. Let us go to the union. If I double click it, you can see over here we have 3 records. These are 3 different polygons. You can see here also, you can see that 3 records and 3 columns. So this is how you can verify it has got 3 different records. Now to dissolve, there is a primary requirement. What is that? Let us see the records. It requires at least one column which is having same value in all the records, but here we do not have a single column with same values. So we have to create one attribute field in which we have to populate the same value, then only we can dissolve. I hope you understand. So what we are going to do is, I'll comment this union plot and I'll add one attribute into union. Adding attribute is very easy. So I'll call this attribute dis underscore attribute, dissolve attribute. So basically when I am giving an attribute name like this. Actually this attribute is not there, you can see it is not present. So when we give any new attribute, it will create it. So we are creating this attribute and I'll updating it with a text value this. Now let me save it and let me execute this thing. So now when I execute this thing, let me take to the variable explorer, let me double click on union. You can see over here it has created an attribute this underscore attribute and it has updated this in all the records. So now we have one attribute which is having common value, same value in all the records. So now we can perform the dissolve based on this attribute. So let us do the dissolve now. So now we have union with this attribute. Now we will do the dissolve. So we are creating a variable and we will use union to dissolve, and we will dissolve by what attribute? The same attribute which we have given here, by this. You have to write is equal to over here. So now it is performing a dissolve operation. Now let us plot dissolve. So what should we expect? Can you just guess it? What we should expect is, we should expect a single polygon which is a dissolve of these two polygons. So let us execute this thing and let us see. You can see over here this is a single polygon which is dissolving all the shapes. So it should be a single record in the attribute table as well. So let us go to the variable explorer. Which variable we will explore? Dissolve, because we are plotting the dissolve. So let us go to the dissolve, double click it, and you can see it is a single record, and that record is nothing but a polygon containing this outer boundary. There are no in between polygons. So here we have performed a dissolve operation. Excellent, we are progressing very swiftly. Now what we are going to do is, we will perform a buffer operation. So let me comment this code and let me use this river variable. So uncomment this thing, let me save it. We will perform a buffer operation on river. So I am just commenting this thing so that we remember that this is a code for buffer. Now what you have to do is, I am just declaring a buff as a variable, and I will use river which I have defined over here. So this is a river shapefile. So I will be creating a buffer on top of river, and then I have to provide the buffer distance. So I will be creating a buffer on river geometry, and then dot buffer. I have to provide the distance parameter is equal to, because it is in meter, let me take some higher value. So I am giving 50,000 as a value. Now let me save it. So what we are going to do is, let me stop plotting AOI 1 and 2. So I will stop plotting that. So AOI 1 and 2, and let me give the fixed size is equal to 10,8 here as well. So we will plot the buffer and we'll give the fixed size 10,8. So let us see how the buffer is working. Let me execute that. So now you can see this is a river and this is the buffer that has been created around the river, and it is having a distance of 50,000 meter. So that is the buffer it has created. Now what if I want to display this river and buffer on top of each other? I am sure you know by now that how to display two layers on top of each other. We have written this code over here. We will write it again. So let us see how to do that. Let me copy this code. Now I have given fig ax plot subplots figure 10,8. Now what I am going to plot is, I am plotting river as blue. River is defined over here, so it will plot river there. Let me comment these lines for now. we are writing already at the bottom. Now I will also plot the buffer, but by default buffer will be blue, river is already blue. So let me change the color of the buffer. So what I will do is I will say color is equal to green and edge color is equal to black. Let us see the output. So what it is doing, basically there is a river file. Here it is doing a buffer of 50,000 meter around the river. Now I don't want to plot the buffer individually, I will plot using AX. Here I have forgotten to give AX is equal to AX so that it plots on top of each other. Now let me save it, let me execute it. You can see river is in blue line and then buffer is with the green fill color and black edge. That is how we have defined over here. So excellent, we have performed a buffer analysis. So gradually you can see we have done multiple things, right from plotting the shapefile, attribute filtering, changing the projection, exporting to shapefile, overlaying shapefiles, performing intersection, union, symmetric difference, dissolve, and then buffer. What next? Do you remember any more geospatial analysis? Let us check how to extract the centroid of a polygon. So let us see that. For time being, I am commenting this line so that it does not plot again and again. So I am commenting this thing. Now let us write something new for centroid. So let me export centroid. So first what we have to do is, for centroid what we will do is we will do the union of area 1 and area 2 so that at least we have 3 different polygons. So again we will do union. So I am writing this code for union over here so that at least we have 3 different polygons. So let me plot the union. So let us again see how it looks like. So when I plot the union, you can see there are 1, 2 and 3 polygons. Now I want to extract the centroids of these 3 different polygons. It is very simple over here. Everything is very simple in Python. Just declare a variable and define union dot centroid, just like that. It is very simple, but remember either you can do union dot centroid or you can define union geometry dot centroid. Both the ways it will work. And let us plot the centroid. Let me save it. Let us execute that. You can see polygon 1, 2 and 3, and these are the centroids of polygon 1, 2 and 3. But it is not looking proper in 2 different separate plots. Let us plot these centroids on top of these union polygons. So how to do that? I am sure you know that. Let me do it once again for you. Very quickly we will do that. So here we have union, here we have centroid. Let us not plot it separately. Let us define fig AX. So let us put it here, and then let us plot union dot plot AX is equal to AX. So I am plotting union and then centroid dot plot AX is equal to AX, comma color is equal to black. Why I am giving the color black? Because by default union will be plotted with blue color, and centroid, if I don't give the color, again they will be blue, so we cannot see that. So I am giving the black color. Now let us execute this thing. So you can see we have polygon 1, 2 and 3, and then we have centroid 1, 2 and 3. So excellent. We have performed centroid extraction program also. Let me comment that. we will move on to the next geospatial analysis, and that is very important one. Many times you require extracting latitude longitude from a CSV file and displaying latitude longitude through a point shape file. So what we are going to do is, for study data I have created airports.csv, which is nothing but all the airports or major airports of India. So I am having latitudes and longitudes and name of the airport. So this is a simple CSV file. Now what we are going to do is, we will convert this latitude and longitudes into a point shape file based on this CSV data. So let me close this, and then let us come to the Python environment. You might think that it will consume lot of memory and it will take lot of time to write the code, but in Python everything is very easy. So let us do that. So what we are doing is read CSV file. So far you see we were reading shape files over here. So read file, and we were giving the path of a shape file. Here when we are reading the CSV file, it is very easy. Let us see. So we will call it airport underscore CSV, and that is what we have to do is, now we will use the panda functionality. It is not GPD now, it is just PD dot read underscore CSV, and what we have to do is, we have to provide the path. So airport.csv, you can see in files I have airports, so you have to give properly airports.csv. so now it is reading that. Now let us see whether it is reading properly or not. So let me execute this thing, and it is giving some error. So let us see what is that error. Airport underscore CSV is equal to PD dot read CSV ARI. You can see over here you have to give proper file name AIR, airports.csv. Let me save it and execute it. So it is executing successfully. Now if I write this airport.csv here, we can see the data in this variable explorer, airport.csv, the variable which we have created. Now if I double click on this thing, you can see it has got ID, name, latitude, longitude, and all the attributes which were there in the CSV file. So now all the details are available in terms of a variable. Now what we can do is, ultimately we have to read this latitude and longitude file coordinates and convert it into a point file. Let us see how to do that. So just understand this code. Now what I am doing is, I am creating a new airport.geometry variable, and I am writing this code. Understand this code. So what it is doing, basically it is using some shapely functionality. So it is reading some file, so I have to provide that file. So in airport.csv it is nothing but the same, and I have to provide latitude and longitude column name. So let me just see over here. So I can write airport underscore CSV dot columns. So I'll get all the attribute columns, and I have to provide this attribute as the first variable, and then comma and then longitude, second variable. So what we have done is, let me explain you this thing. We are creating a point xy file, and for that we are reading through a zip, and in that we are providing the CSV as the input, and which attribute we want to read, those latitude and longitudes we have provided. So basically it will create airport.geom variable. Let me execute that, and let me show you how it works. Here I have to provide this thing in a string format, so don't forget that. That is why we were getting this error. Let me save it and execute it again. So now it is executing successfully. Now let us check the content. So what is the difference between airport CSV and airport geom? Let us see that. So first of all, I am writing airport underscore CSV, enter. So you can see over here it is nothing but a table which has got ID, indent, latitude, degree, longitude and some other attributes. But when we see airport geom, let us see that it has got a geometry. You can see, so we have converted latitude longitude into a shapely geometry, which is nothing but a point file, and that is the difference. Now from shapely geometry we have to convert it into a Geopanda data frame, which we can export or do some spatial analysis. So how we will do that, let me show you over here. So I am creating a new variable airport data frame, that is equal to gpd dot geo data frame. You can see we are getting the help from the IDE data frame, and here we have to provide this CSV as an input, and then geometry it has to take from this geometry. At the same time we have to provide CRS, spatial reference. So from where we will provide the CRS now, because we are converting this latitude longitude into the shapefile, so coordinate system will be EPSG 4326, that will be the coordinate system. Now what if we want to take the coordinate system from a existing shapefile rather than specifying it explicitly? So let us see how to do that. In files we have Gujarat 4326, we can use that shapefile and takes its projection system and assign it here. So what we are doing is we are converting shapely point geometry to a Geopanda data frame. For that we have provided CSV as an input for attributes. Geometry wise we are providing shapely geometry, and for coordinate system we are using this Gujarat 4326 shapefile, and we will use its coordinate system. So how we will do that? Let us write here Gujarat underscore 4326 is equal to, how to do that, can you guess it? GPD read file R and then provide the file name. So this is the shapefile path we have provided. Now here we need, whenever we have any shapefile in the geodata frame, then we can simply use the CRS functionality. So Gujarat underscore 4326 dot CRS, that is how we can use it. So we will use it here. So I'll just copy this thing and I'll provide this thing. Airport underscore DF. So what we should expect? We should expect a point shapefile to be plotted on the screen. So let us execute this thing. So you can see over here all the airports are displayed in terms of a point file. Now we want to display this point file on the states file. So what we will do is we will first of all convert this shapefile from 4326 coordinate system to 3857, because our states file is it into 3857. So we can use this variable and we can check the coordinates reference system CRS, it is 3857. Whereas if we check the airport DF, because we have created airport DF from latitude and longitude, its coordinate reference system is nothing but 4326. So we have to convert airport DF file from 4326 coordinate system to 3857 so that we can display it on a states file. So doing it is very simple. We have already seen it how to do it. What we will do is airport underscore 4326 is equal to airport underscore df dot to underscore crs, and EPSG code is equal to 3857. It is very simple, such a simple thing to do. And once it is created, what we will do is we will display it. So how to display? We have done it multiple times so far. So we will define the figure with axis and then we will display first of all state. So let us copy and paste it for displaying state. So we will plot it from here. So states will be copied. So we are plotting states here. Now we will plot airport. So we will plot airport for this is where we have to write 3857 because it is having EPSG 3857. So we will plot airport 3857 dot plot. Let us save it, execute. We should expect India state file displayed with airports, but why it is two different? Because we have not provided axis common. So we will provide that, execute that. You can see over here India states with airport location. So we have performed CSV conversion to a point shapefile. Excellent. Now let us see the content of airport 3857. Go to the variable explorer, go to the airport 3857, and you can see the attributes were coming from CSV file. The geometry was coming from latitude and longitude. So we have name of the airport and then latitude and longitude and other information. But somehow we don't have states of the airport. What if want to have it in this airport shapefile? Can you tell me what to do if I want to have state's name in the airport point shapefile? What to do? We have to perform spatial join. Spatial join of airport point file with the state boundary. So let us see how to do that. So I will first of all comment all the previous code of plotting. So I am commenting this thing. Now let us see how to do the spatial join. So let me write here spatial join. Let us see how to do that. So what we have to do, we have airport one point file, states another point file. So what we will do is we will write airport with state name. So this is a variable we have created and we will use gpd.asJoin, that is a spatial join, and we will have airport 3857 as one of the input. Second input, as you have expected, it will be states file. So I'll take states file as a second input, and then I'll provide how to do the spatial join. So it has to take inner. So whichever airports are within the state boundary, it will be given the name of the states, and it will basically inside perform intersection. So whichever is airport point file intersecting with the state file, it will take the name of the state value. So this is a very simple spatial join, such a beautiful thing. Earlier when I was writing codes in ArcView A1 new language or say Arc objects, it used to take long list of lines to perform this operation, but now it is very simple. So we have performed a spatial join, and now we have a variable which is containing geometry as well as airport name as well as state name from the state file. Let us save it, execute it. it has executed. Because we are not plotting anything, it is not plotting, but we can see in a variable explorer airport with state is a variable. And now when I double click it, I am expecting a state name field added into that, and yes, I have name field, which is nothing but a state name: Andaman, Nicobar, Andhra Pradesh, all the states which are containing airports. So a new point file has been generated which is having a state name that is coming directly from this state shapefile. Now what if I want to export this new point file with all the attributes to a shapefile? You know by now how to export. So it is very simple, just copy this thing and dot to underscore file. It is very simple, and then give the file name. So I'll give the same file name dot shp, and then what else? We have to provide the driver. You remember it correctly, esri space shape file. So it is the file which we have to create. And now when I execute it, let us go to the console, let me execute it. We are not plotting anything, so code will execute. It has executed. Now when we go to the files tab, we should see a shapefile airports with state.shp. Let us see over here, and let us yeah, you can see over here airports with states.shp. A new shapefile has been created. So excellent, we have performed lot many spatial analysis using Geopandas. If we again have a look at it, we have plotted a shapefile, we have also applied attribute filter, we have changed the projection, exported to shapefile, we have performed overlay of multiple shapefiles, we have performed intersection, then union, followed by symmetric difference, then difference and dissolve. We have also performed buffer analysis, we have extracted the centroids of the polygon, we are reading a shapefile, or we are reading a CSV file and converting latitude longitude into a point file. We have also lastly performed a spatial join. So it is lot many kind of analysis we have performed in a single shot. Thank you for your time and attention. Thanks for watching.